Let's suppose uh, question is find the given system is with memory or not. This is the question. Find the given system, and what is the system? System is given yt is equal to 2xt. This is the system equation. Okay, so if you want to draw the block diagram of this equation of this system, so this is the system, this is the output yt, and input is always xt. And what is the value of yt? Yt is 2xt. Okay, so what this system is doing, system operation is, if you give any input, then it multiply the input by 2. So xt is the input. If this xt go into the system, this system multiply the input by 2, and the output is 2 multiply input. Let's suppose example, if you give xt is equal to 2, let's suppose xt is equal to 2, go into the system. What system do? Multiply by 2. So output yt is equal to 2 multiply 2. Answer is 4. This is the system. This is the meaning of this equation. Now how to find out that this system has memory or not? So there are two simple steps. First one, let's suppose time is equal to 0. Okay, put time is equal to 0. So y0 is equal to 2x0. Y is equal to 2x0. Now if we talk about timeline, let's suppose this is the timeline. This is 0, this is 1, 2, 3, this is -1, -2, and -3. Okay, so you can see here, output is where? Output at 0. This is the output. And where is the input? Input is also at 0. Input is also at 0. So output and input both are at same time. So we can say, or if you want to take one more example, you can take one more case. Let's suppose t is equal to 3 or any number. So y3 is equal to 2x3. So where is the output now? In the second case, output is at 3. Output is here, and this output depends on input at 3. So input and output both depends on same time. So you can write, given system given system does not have memory, or you can say without memory. This system is without memory. It depends on your language how to write. You can say this system is without memory. Okay, now second question, I take one more example. Let's suppose system is given like this: yt is equal to 2xt minus 2. Okay, now the solution, same steps. First one, t is equal to 0, put t is equal to 0. So y0 is equal to 2x 0 minus 2. So what is this? Y0 is equal to 2x, this is x, 2x minus 2. So if you draw the timeline for this, now you can see here, output at 0, and where is the input? Input at -2, input at -2. So you can see here, output depends on past value of input. Output depends, this is past for 0, and this is future. If with respect to 0, this is 0. So this is future, 1, 2, 3, 4, 5, 6. This is future with respect to 0, and -1, -2, -3, -4, -5. this is passed for the with respect to 0. Okay, so in this first case we can say output depends upon the past value of input. I take one more case here. T is equal to, let's suppose, 2. So y0 is equal to 2x 2 minus 2. So what is the, oh sorry, this is 2. So y2 is equal to 2x0. So if you draw the timeline for this, so y2, where is y2? This is 1, this is 2. So y2 is here, output is here, and where is the input? Input at 0. Input at 0. This is the input, x is 0. So you can see here, with respect to y2, input is where? X0. So output depends on past value of input. So you can write the answer. So so given system, given system has memory. That is the answer. Given system has memory. Okay. Now come to the next property. Next property, I am telling you, stability. Stability, or BIBO. Easy one. First I am telling you easy one. BIBO, stability. Okay, what is stability? Now let's suppose I have a system. This system. Okay. And if the input of this system is in the daira, in the range, and output is also in the range, then this system is called stable system. Let's suppose in my mobile, if I press 5 and the output is also 5, then I can say this system is stable, because the input is in daira and output is also in daira and the correct one. So I can say system is stable. If I give input, let's suppose 6, but output is but on the display output is, let's suppose, 100, what can I say? I can say input is good but the output is not good. So this system uh, mm, uh, is not stable. This system is not stable. This is the meaning of stability. Okay. And the last property for today is invertible. Okay, this property I will tell you next class. First one, we will go to the slide again. We go to the slide again and we find out the stability definition. Okay. So this is stability. You can find here stability. A system is called stable if it produces bounded output for all bounded input. BIBO, bounded output, input should be in daira and output should be in daira. It produces bounded output for all bounded inputs. That is called stability. Okay. uh, you can see the example. This is, let's suppose, a ball, in the kitchen, the cup. Okay, and this is the ball here. And if you put a ball inside the cup, and if you press a small force, then the ball is in the cup. Okay, the cup is a system, and ball is the input. And you when you put the ball inside the cup with a proper force, with a bounded input, then ball keeps in the cup. But if you put the ball with high force, then what will happen? It will go out of the cup. So in this case, in the second case, when you put the ball with the force and it goes out of the cup, then in this case, input and output is not bounded. But in the first case, when you put the ball in the cup with a proper force, then the ball keeps in the cup and it is moving. It means you give the input proper and you get the output proper, bounded. Okay, so this is the meaning of stability. Next property, next two properties or maybe three properties I will tell you in next class. Watch the video. If you have any doubt, if you feel any problem, you can ask me in the next class or in the group WhatsApp group. Thank you.